Hello, and welcome to Writer Rant, author advice in 5 minutes or less because I have to get back to writing and so do you. So a couple weeks ago, I talked about time travel and how a lot of times it's not really accurate in terms of the physics of it in a lot of the content that I see today, both in movies and TV shows and in books. So in the space-time continuum, if I'm talking about time, the other side of that is going to be space. And I know there's a lot of excitement about all the exoplanets that we're finding out there. You know, it's a really exciting time for astronomy to kind of see, oh, hey, here's this system and it's got an Earth-like planet on it, or here's this system and it's really close by and it's got a planet on it. And, you know, it's really exciting that we can find all of these different planets so close to our solar system. The trick is, how do we get there? And that's something that I don't think the general public has really thought about yet. And the reason for that is that while we understand and we kind of work in a three-dimensional world, space is truly three-dimensional. And that's something that we often forget when we say, oh, well, there's this closest star, it's Alpha Centauri, you know, it's up in that constellation. And it's like, okay, yeah, that's the closest star, but unless you can get there directly, yeah, it's not going to happen. The real trick is that, especially in our Earth system, in their solar system, everything's kind of in the same plane. Everything's kind of flat. Like if you look out at the sky and you see the planets, you can kind of see they're almost all right on the same line across the sky. And so the trick is that when we right now use those planets, it's for gravitational slings. We essentially use the gravity of those planets to make ourselves go faster and get out of the solar system. That's how we did the New Horizons probe. That's how we did the Voyager probes. And you know, they're only going about 17 kilometers a second. Now that's fast. I'm not going to lie to you. The trick is that it's not quite fast enough. So if we want to actually escape the solar system, we have to be going probably 3 times that speed. We have to be going about 42.1 kilometers per second just to get out of the solar system. So even though Voyager, New Horizons, and all those, they're way out there, they're still being attracted by the sun. So if we can get faster, hey, we can get out of the solar system, and that'd be great, except if we're using those planets, we can only go in the ecliptic. We can only go in that same plane. And they don't line up very often. In fact, when they did the Voyager program back in the 70s, that was their best chance to get as much gravity assist as possible. And so if that's the case, any planet we find would have to be on that same plane, because otherwise it's going to be too difficult to get out of that plane and get to somewhere new. Go talk to some astrophysicists and some orbital mechanics. They'll tell you why that is. So then here's the other trick. We're in the Milky Way. The Milky Way has its own gravity too. We have to be going almost 500 kilometers a second just to escape the Milky Way. So with those two things in mind, if we're going to travel to any other planet that's not in our solar system, we're probably not going to have enough speed to get outside of the Milky Way. So with those two things in mind, it's going to be on the ecliptic, and it's going to be intersecting with the Milky Way. And most of the zodiac constellations are on the ecliptic, which means we're pretty much going to be in Sagittarius if we want to get to any planets, and it's quite a ways away. Anyways, something to think about. This has been Writer Rant, and I'm Benjamin M. Weilert. If you have anything that really bugs you about any of the physics that's out there right now that people aren't thinking about, drop a comment below and maybe I'll get to it. Thanks.